In this video, I'm going to explain the three cases for work. As long as work is a function of cosine theta, and we know that cosine theta could be positive, could be zero, could be negative. This affects the result of the work and the sign of the work. So the work also could be positive, negative, or equal to zero. In the first case, work is said to be motive if its value is positive. Already F and D are positive because they are magnitudes of forces. Now what it changes is the sign of the cosine. So if F and D is between 0 degrees and 90 degrees, which means it belongs to the first quadrant, cosine of this angle is going to be positive and thus the work is positive. This is the case when F and D vectors have the same direction. Case 2, work is 0, so there is no work exists. This is when F and D, when the magnitude of F and D, when the angle, between F and D is equal to 90 degrees, and thus the cosine of the angle between them is 0. So the work is equal to 0. In this case, F and D are perpendicular. There is another case that we already mentioned. If no displacement is done, this means if D is 0, then F times D times cosine is going to be equal to F times 0 times cosine, so it's going to be 0 again. So work is 0 whether the angle between the force and the displacement is 90 or if the displacement is 0. No work is done. The third case is the work is said to be resistive if its value is negative. Again, it gains this negative value from the cosine. If the angle between F and D vectors is 90 to 180, this means it belongs to the second quadrant, then cosine FD is less than 0 and thus the work is less than 0 because F times D times cosine, positive times negative is going to be negative. And in this case, F vector and D vector have opposite directions. Application. A 2 kilograms block is pulled by horizontal force along a rough horizontal plane from position A till position B. By horizontal force, they mean this capital F. The magnitude of the horizontal force remains constant. This is a very important condition. F equal 10 Newton. The force of friction between the plane and the block has a magnitude of F equal to Newton. As long as this block is being moved along a rough surface, this means that the rough surface exerts a friction force on it opposite to the direction of motion. So F is represented in a direction opposite to the direction of the motive force. Now, given that the gravitational acceleration is 10 meters per second squared, part 1, name the external forces acting on the block. Calculate the work done by each force knowing that the block covers a distance of AB equals 10 meters. And then deduce the network on the block. Is it motive or resistive? Name the external forces acting on B. The given ones, the directly given ones, are the motive force F and the friction force small f. The ones that you should know are the gravitational force, because you know any object on Earth is subjected to the gravitational force, or the one that we call weight, which is always vertically downward, pointed towards the center of the Earth. And the normal reaction of support, as long as this block is not moving downward due to the effect of the weight, this means that there is another force pulling it upward, preventing it from falling down. This force is exerted by the support on the block. Okay. Now calculate the work done by each force, knowing that the block covers a distance of AB equals 10 meters. So now we have to apply the formula. Work by the weight is the weight, the magnitude of the force, times AB, which is the distance, times cosine the angle between the weight and AB vector. AB vector here is represented by a red arrow showing the displacement from A to B. The weight, you know from previous years that it's equal to the mass times the gravitational acceleration, times AB times cosine 90. So AB, the magnitude or the angle, between AB vector and W vector is actually 90 degrees. They are perpendicular to each other. That's why we say here cosine 90. So doing the substitutions, 2 kilograms, kilograms is the SI unit of mass, times 10 meter per second squared. Meter per second squared is the SI unit of the gravitational acceleration, times 10 meter, meter is the SI unit of distance, and times 0, cosine 90 equals 0. You have to go back to the notes about the trigonometric circle. So any number multiplied by 0 finally is equal to 0 joules. So the work done by the weight is equal to 0 joules. This means that the weight is not participating in the movement of the object or of the block from A to B. It doesn't play any role here. The work done by it is 0. Now the work done by the normal reaction of support is equal to the magnitude of the force times the displacement times cosine the angle between n vector and AB vector. Now n is not given. We are not given the magnitude of the normal reaction of support times AB times cosine 90. In this case, we are not interested in having the magnitude of the normal reaction of support, but I'm going to explain how we can find it. So far, because also n vector is perpendicular to the displacement vector AB, so it's not playing any role. The angle between them is 90 degrees and cosine 90 is 0. So again, the work done by the normal reaction of support is equal to 0 joules. And if the cosine was different from 0, then we need n to calculate the work. But n is equal to the weight because the object is at equilibrium vertically. It's neither moving upward nor downward. This means that the force pulling upwards is equal to the force pulling downwards. So the magnitude of normal reaction of support is equal to the magnitude of the weight, which is m times the g, 2 times 10, 20 Newton. Now as for the motive force and the friction force, again magnitude of the force times distance times cosine. The magnitude of the motive force is 10 in Newton, 10 meter times cosine 0. Why is the angle between F vector and AB vector 0? Because they are directed, because both are horizontal in the same orientation and the same direction. So the angle between them is 0. So 10 times 10 times cosine 0 means 100 times 1. The friction force is participating in, the motive force is participating in the motion of the object here, and the work done by it is 100 joules. This is a motive work done by the motive force because the work is positive. Now what about the friction force finally? It's equal to the magnitude times AB distance times cosine the angle between them. So let's check the angle between the friction force and the displacement vector. I just redrew it on the blank part. F is to the right, AB is F is to the left, AB is to the right. So if we represent them starting from the same origin, we can find that the angle between them is 180 degrees. So cosine 180 degrees equal minus 1. Go back to the trigonometric circle and check it. So 2 times 10 times minus 1, it's equal to minus 20 joules. So the friction force is participating in opposing the motion. It is resisting the motion of the block by the motive force, which is F. So now deduce the network on the block. Is it motive or resistive? W total is equal to work done by weight plus work done by normal reaction of support plus work done by the motive force plus work done by the friction. So 0 plus 0, 100 minus 20 equal plus 80 joules. So is the total positive or negative? It is positive, so it's a motive work. This means that if you want to study, if you are asked that, suppose this object is subjected to the 4 forces, does it move from A to B or not? If the total work is positive, then yes, it moves from A to B. If it is 0, then no, it doesn't move. And if it was negative, then it moves in the opposite direction.